So this is a little video about how to do this graphing activity that's in Google Classroom. I've been getting a few screenshots of graphs. Remember that you get points for the graph based on making your graph in a spreadsheet. So be sure that you make it in a spreadsheet. Don't just send in somebody's screenshot. The instructions for doing this are on the first part of the handout. There's also a video that I made that explains how to do it, and that's also posted on my web page. It'll be beside the link for this video. All right, so you have to make the graph. After you make the graph, we want to answer these questions. And this video is about how to read the graph to answer the questions. So the graph is atomic radius versus atomic number. And the first question says, what is the biggest element on the graph? So radius is on the y-axis and atomic number is on the x-axis. And I think that you can see that the biggest element on the graph is potassium. Well, we know it's potassium because it's element number 19. You can see this is 20. This is 15, so that'd have to be 16, 17, 18, 19, 20. So number 19 is potassium. So the answer to that is potassium. The smallest one on the graph is over here, and that is element number 2. So you can tell 5, 4, 3, 2, 1. So this is 2. Number 2 is helium. Now, which is larger, lithium or oxygen? Well, lithium on the periodic table is element number 3. Oxygen is element number 8. So you look on the graph and find element number 3. 1, 2, 3. And element number 8, that's 10, so 9, 8. So now which is larger? Well, it's lithium. Using the same logic, sodium is atomic number 11 and sulfur is atomic number 16. See, sodium is 11, sulfur 16. So which is larger? It's going to be sodium. How does the size change from lithium to neon? Well, lithium's number 3, neon's number 10. So it gets from 3 to 10, the size gets smaller. So you say decreases. How does it change from hydrogen to helium? That's number 1 and number 2. Decreases. How does the size change from sodium to argon? Sodium is number 11, argon is number 18. Number 11, this is number 10 right here, so number 11 is here, number 18 is over here. That's 20, 19, 18. So again, it decreases. So within any row, this is the beginning of a row, that's the end of the row. That's the beginning, that's the end, that's the beginning, that's the end, that's the beginning, that's the end. Within all of the rows, the size decreases. Okay, so I've been trying to get you to realize that as you go from left to right on the periodic table, the size decreases. Now, which has more protons, sulfur or silicon? Now, here's sulfur, here's silicon. Sulfur has more protons, 16 versus 14. So the answer to that one is sulfur. Which is smaller, sulfur or silicon? So this was element 16, that's element 14. So you go back up here, 15, 16, 15, 14. So that one is silicon. That one is sulfur. So it looks to me like sulfur's smaller. Which has more protons, sodium or argon? Sodium is 11, argon is 18. So argon has more protons, which is smaller. Also argon, because remember, sodium was number 11, right here. Argon's 18. So far, how does more protons affect size? Okay, now this is the Y, and we haven't talked tons about Y in class. That's why I was making this video. Okay, so the Y is more protons make the atom smaller. What that means, the reason why that is protons are positive, and the more positive charge you have, the more if you have electrons out here and you have positive in the middle, the bigger this positive number gets, the more the protons or the electrons are pulled in tighter because there's more attraction. It's like a stronger magnet pulling them in, except it's electrostatic, but it's kind of the same idea, kind of like a magnet. So the more protons you have, the more the electrons are going to be pulled in, at least as long as you're going across the series. Okay, now arrange these from small to large. So lithium, potassium, sodium, hydrogen. Lithium's element number 3. I'm going to put check marks here. Hydrogen's element number 1. Sodium's number 11. Potassium's number 19. So if we're going to put them in order of from small to large, the smallest is hydrogen, then lithium, then sodium, then potassium. So hydrogen, lithium, sodium, potassium. Arrange these from small to large. Argon, helium, and neon. So this is number 18, that's number 2, that's number 10. And we know that from the periodic table. 18, 2, 10. And then if we look on the graph, 18 is here, 10 is here, 2 is here. So it looks like helium's the smallest, and then neon, and then argon. So helium, neon, argon. All right, the next question says, which is larger, O or S? So O is number 16, S is number, no, sulfur is number 16, O is number 8, sorry. So number 16 was sulfur. Number 8, 10, 9, 8 is right here. That's oxygen. So which is larger? Oxygen, sulfur. Sulfur is. So sulfur. So how does size change going down a column on a periodic table? It gets bigger. Or you could say increases. All right, now which has more protons, sodium or potassium? Sodium has 11, potassium has 19. So potassium. Which is smaller, sodium or potassium? Again, this is number 11, that's number 19. So look over here, number 11 is here, number 19 is here. So which is smaller? Na. Now go back. Does this question still make sense? Go back to 13. It says, so far, how does number of protons affect size? And we said more protons, I forgot to write the word protons, more protons make the atoms smaller. Does that make sense here? Because potassium has more protons than sodium, 19 versus 11, but sodium was smaller than potassium. So the answer is no, not really. So what other factor besides the protons might affect the size, and that is energy levels. Because what happens is the inside electrons repel the electrons in the outer shell. Let me show you a picture. So if you have an atom that looks like this with these energy levels, and you have an electron sitting out here, all the electrons on the inside are negatively charged, as is this one. So these inside electrons push that away. In effect, we do what I always call shielding it. They shield this electron from the positive attraction of the nucleus. And so the more of these energy levels that you add, the more inside electrons you have, and the more the outer shell is pushed away. So the atoms get bigger when you add more energy levels, and that is more important than adding protons. When you add protons, as long as you don't add a new energy level, they get smaller. But when you add a new energy level, that's a more significant change, and the atom gets bigger, even though there are more protons. So, to summarize it, as long as atoms are in the same horizontal row, more protons will cause the atoms to be smaller. When moving down a column, though, the addition of energy levels shields the outer shell from the nucleus. That causes the atom to be larger, even though there's more protons, because as long as you're in the same row again, atoms get smaller. Remember our picture from today, they look like this. But as you go down, they look more like that. Like this, across this, going down. So as you go down, the atoms get bigger because you're adding energy levels. Every new row is a new energy level. All right, so bottom line, atoms get smaller when moving from left to right, and they get larger moving from top to bottom. The reasons are more protons when you go this way. Here you also have more protons, but energy levels are a more significant factor, and so the addition of energy levels causes them to get bigger. All right, so that's a little summary of this chart. Remember, this graph needs to be created by you, not screenshotted by you. And on the quiz on Monday, there'll be questions about the graph. Like I might say, how does size change from neon to, or from sodium to argon, for example? And you'd say it gets smaller. But if I said, how does size change from neon to sodium, you'd say it gets bigger. So you'll have to interpret that element number 10 is neon, number 11 is sodium. Okay, that is the end of that little video. Hope that helped.